Good morning, good afternoon, good evening to everyone from wherever you're joining us. This is the Keshe Foundation Spaceship Institute public teaching in English for Monday, October 23rd, 2017, with Jim and Lisa McDonald and Sandra Kakasi. And today is part 5 of Understanding the Plasma Science series. And today we're going to be covering, of course, plasma science and creation of GANs. I'm your host, Flint Mulhausen. Welcome, everyone. Glad you can be here, and welcome, Jim and Lisa Sandor.
Thank you, Flint.
Yes.
Screen. Can you see that?
Yes, we can.
Okay, great. All right, welcome everybody to part 5 of Understanding Plasma Science. And today we are going to be working on understanding a bit more of the science, and then on the GANs making, we're going to be looking at the CO2 and one method of the zinc GANs. And the technology is brought to you by the Keshe Foundation. And Mr. Keshe, for the last couple of years, has been doing public teachings, and so we've just tried to take this information and put it into a condensed format that everybody can get a bit of an understanding to help them on their journey of understanding. And you can go to the 2 websites there for further information. So we'll do a bit of a review just to get our minds thinking on the science part again. And so the science is essentially going beyond what we've always known as the matter state. And we're beginning to understand that it's not magic. It's just and it's what we have not understood as yet. And as we're beginning to unfold and understand the science, it becomes a bit more clearer. And we begin to understand that everything in this universe and beyond is made of these fields. And we have the principle of the magnetical and gravitational, the mag-grav fields. And we know that everything is a dynamic interaction of these fields, and we only see these fields when they slow down enough to become the matter state for our eyes can see. And when we review a small review of part 2 that we dealt with, plasma can be made of millions and millions of fields that come together and interact continuously. So when we've looked at from the cells in our body to the galaxy, the universe, all is a plasma and operates in the same way. And the whole universe is built on these interactions of these fields. They're in constant motion, going from one place to another, depending on their strength and depending on their position. Right, so now we're going to continue. And today we're going to have a look a bit more in detail at the magnetic rays and plasmatic magnetic fields and what they mean and what are they. Before we start, will you be able to play that video, Flint, just to refresh everybody?
Yeah, just getting it around here.
Caught you off guard. Put it very early.
Yeah. So what we have here is a animation, of course, that shows a plasma ray interacting with other rays to form plasma entity.
Thanks, Flint. It was just a bit of a refresher, just to so that people know what we are going to be talking about next. Okay, so we've watched that video, and what we're going to go into a bit more detail and a bit of understanding is what are these magnetic rays that come together and form the plasma. What they can be are essentially the individual and directional magnetic forces. So if we have a look at what this ray is, in the center, we call it the principal matter, or the very principal field. And around that is the transition, and then you get the matter on the outside. So it's composed of three different sort of field strengths, and it's in an elongated form. And you'll see it's got a north and a south on that elongated form. So in that shape, it would look like a bar magnet with your north and south. And when you look at the cross-section side of it, it also has the north and south. So these magnetic rays are the individual rays that come together. So another way of explaining them is it's a cylindrical version of the spherical plasma, like the proton or an electron. And this magnetic ray is in possession of its own magnetic and gravitational fields, and hence has its own magnetosphere. So it's only in a cylindrical shape compared to the round plasma. Otherwise, it can essentially be that plasma, but it's the plasma in motion, which is what we call it, the magnetic ray. And the plasma takes the shape of a ray when it travels from one point to another. And the important part here is that the magnetic ray will possess the same magnetic or gravitational properties as its source. So whether it be the sun or ourselves, it possesses those fields which come out from its original source. So then the next question comes to mind as to where do these magnetic rays come from? And in our solar system, principally from our sun. Sorry, there's a bit of a delay in our slides coming through. So when we have a look at the sun and the earth as two separate plasmas, the sun is giving fields into its environment, and essentially what is not needed is taken back in on a continuous basis. So that's we've understood before. The fields that are given into the environment of the solar system will travel from the sun to the outer edges of our solar system and back towards the sun. because if we got to view the sun as the principal field of our solar system, so the magnetic rays coming from the sun will travel to the outer reaches of our solar system, which we can view as a plasma, and what is not, and these will come back in again if it's not needed beyond the solar system. So it's these magnetic rays which are given off from the sun, which interacts with all the other plasmas, be it the Earth. So one has to take a view that our solar system operates just like a smaller plasma. And when the magnetic rays from the sun reach the magnetosphere of our solar system, and it then flows back into the sun. And we've got obviously the different planets in different positions within that solar system. But in that, essentially the magnetic rays are traveling from the central sun out and back in again. So the void in outer space is filled with these magnetic rays and plasmatic magnetic fields, which we will explain. And it's even here the same on Earth as in outer space. This empty space around us is filled with magnetic rays and plasmatic magnetic fields. And I've just used this photograph to illustrate with it raining that, we can see these rain drops all around us. And if one had to try and visualize what these fields around us would be like, I can only just try and illustrate it as rain that's falling down. It's something that we can see that fills everything around us.
Another good example would be the rainbow.
Yes, yeah. All right, so I'm going to just read a quote. There are no regions in space, in the universe, which are void of magnetic rays or plasmatic magnetic fields, and their gravitational interactions and attractions with respect to one or more magnetic field or magravs, depending on their proximity with respect to each other. It's a bit of a complicated quote, but it is essentially saying that nothing is void of these fields, and it's, even though we don't see them, they are in constant motion around us. These rays also come from the central sun of our galaxy and our universe. So we have to also say that the magnetical rays of different strengths are given off from the sun, the galaxy, and the universe. There is no one which has identical strength. So we have billions of rays of all different strengths given off from the sun and the central galaxy and the universe. And then we go into the next understanding of what plasmatic magnetic fields are. So plasmatic magnetic fields are detached from their source of creation, hence the use of the term plasmatic. For these magnetic fields and an environment containing a certain amount of rays of magnetic fields. So plasmatic refers to a collection of dynamic magnetic fields. So this is the soup of fields from which everything is created. So in plasma science, calls these plasmatic magnetic fields, or abbreviation PMTIC. So when one starts understanding and reading the books and a lot of the teachings, the public teachings, and even in the private teachings, you'll see that Mr. Keshe refers to a lot of these abbreviations, and so one has to start understanding these to really understand what is being taught. And so a simple definition, a simple understanding of what plasmatic magnetic fields are is that they are a dynamic collection of magnetic rays. So we now know that we have these magnetic rays out there, and we have a collection of these rays that might be of similar strength, which we'll call plasmatic magnetic fields. So now with our magnetic rays, we've got to look at how a plasma is formed and what is involved. So we get at least two magnetic rays interacting in a dynamic way, build the next larger entity known as a magnetic field. So we're going to explain that. As was shown in the video, you have the magnetic rays coming and interacting. So you get the rays of similar or very similar strength come and start interacting with each other, and you get the beginning of the creation of a plasma. Because if one views these magnetic rays as tiny little elongated magnets that can come together and start interacting and creating that dynamic interaction between the two. So in this essence, we have the initial seed of that plasma that's created. And when you have the two interacting magnetic rays, it leads to the creation of a magnetosphere with its own magnetical and gravitational field strength. So that tiny little entity now has its own magnetical gravitational strength from the combination of the two, creates it's a new strength. So now this plasma with its own specific magnetical gravitational field strength will now start interacting with other rays and plasmatic magnetic fields to build a larger entity. It gets more interaction of these fields. Now this is just a very simple basic understanding. The process is a lot more complicated, but I'll try and keep it simple so that people can understand the very basics. The books go and a lot of the workshops go into a lot more detail, but hopefully this just gives people an idea. So these magnetic rays or fields and their collection as plasmatic magnetic fields become known as the initial fundamental particles. Therefore, we consider magnetic fields to be the real fundamental particles in the world of creation, because they're all around us, and it's this interaction of them that starts creating that initial seed of the plasma, which can lead to the creation of a new planet somewhere. And these magnetic rays can also be called the fundamental particles, which come together to create the initial seed of a neutron. And our current science and understanding will call it a fundamental particle, but it's just the interaction of these magnetic rays will lead to everything that we see around us. It's this interaction and forming a dynamic interaction between all these fields creates and under the certain conditions will manifest what is needed in that condition. So it's essentially the world that we don't see. The existence of magnetic gravitational forces and the existence of a magnetosphere of the plasma confirm the existence and interaction of at least two plasmatic magnetic field forces within that structure. So all the magnetic fields and plasmatic magnetic fields are dynamic and in a state of motion constantly. So these magnetic fields are always attracted by or interacting with other magnetic entities. Thus, they're always on the move towards or repulsing from one magnetic field to another. So what we see with our eyes around us is very much static motion of the universe, but what we don't see is in constant motion. So in other words, what we see as the plants and animals around us, we would consider that static motion. But what we don't see beyond that is in constant motion and interaction. So essentially, our magnetic rays and the collection of magnetic rays are essentially the building blocks of our universe and all that we see. So everything stems from the interaction of these fields. So the vastness of what we don't see contains these magnetic rays. And when these magnetic rays start interacting with other rays of similar strength, they're called plasmatic magnetic fields, independent and constantly moving and interacting. So essentially plasma moving from one point to another. And so from a large plasma like the sun, we get the magnetic rays, and the rays of similar strength form plasmatic magnetic fields, and under the right conditions, these start to interact to form a new plasma. So I hope that made sense. It is quite a complicated section, but it is important to understand the sort of fundamental building blocks of everything and how these interact. So are there any questions?
Okay.
Jim, this is Rick Cram.
Yes.
One point that came up in that video of the plasma and of the magnetic rays is Mr. Keshe mentioned that it doesn't always require two or more of those rays. It could actually be one that forms a plasma, in that it can turn from a ray and basically sort of like the snake that eats its own tail analogy.
Okay. Yes.
Sort of turn on itself and become entwined and become a plasma, or however it does that. But that came up, maybe a few months ago now, but relatively recently. And this clarified that. And it makes sense in a way, because those are principal rays, as in, you know, does it take two creators to make a plasma or one creator? So you kind of think about that.
Okay, thanks, Rick.
Yes, thank you, Rick. John Wells, you had your hand up. Do you have a question?
Oh, my microphone. Can you listen to me?
Yeah, we hear you.
Ah, fine. I'll put a bit more volume to it then. Can you copy me correctly now?
Yeah, you're good. Go ahead.
Fine. I'd like to clear some definitions here, because Normally we have a toroid or toroid where magnetic field comes out of the upper part and the lower part. We got the sort of the donut effect of the fields. Now the light comes from the center of this, if we could call it the Caroline core, and it goes straight out. What is the difference between the field of the light and the field of the magnetic field? Because they cross each other. Do we
Yeah,
get
but the light doesn't come from the center though. Light comes from the interaction of the fields, the rubbing, the friction of the fields. The
well,
light is a remnant of what we see. The light is just something that we see, but the
exactly.
magnetic ray is principle. Sorry, go ahead.
Yeah, now I get it. The light is the effect between the magnetic field and matter.
No.
No, two different strengths of magnetic fields.
Right. It's the friction of the fields. It's the leftover of what is what we see.
In light is a small bandwidth, which only our eyes happen to pick up.
Well, yes, but you consider heat also the effect of light, of the field.
Again, yep, interaction of the plasmatic magnetic fields upon another entity's fields.
Now, those fields come straight out of the source, doesn't it? Because light only comes straight out of the source.
Okay, if you imagine the
well, sorry, go ahead.
Oh, I was going to say, if you imagine the rays coming out of the sun, 360 degrees, they're just coming out all directions. And the ones that happen to interact with the magnetosphere of the Earth form the light. Light isn't formed until it interacts at a certain frequency or bandwidth of fields that we just happen to pick up with our eyes.
Yeah,
the scientists say that, think about it this way. Do you think the light comes from the very center of the sun?
No. It's the effect of the fields.
Okay, yeah, because even the light rays that are inside the sun, apparently, if they are, that's what the scientists say, it takes days and days for that light to exit the sun because of its intense gravity. The light travels very, very slowly within the sun, and won't travel necessarily in a straight line because of all the turbulence and so on.
Yeah,
so it's only the stuff coming off the surface of the sun that we see as and only through our interaction with the atmosphere and so on are we getting results from that.
We see a great difference there now. There's a light that starts supposedly on the outer skirts of the sun, and that takes 8 minutes and 20 seconds to reach the Earth. But supposedly the light is created by the field effect of the magnetic field when it hits the atmosphere of the Earth. That's what I want to clear those definitions or the differences.
Well, John, you're
Yes.
getting a bit beyond what we've discussed today. So I'll have a look to see if we can bring that one in, because we are going to be looking at the interactions between the sun and the Earth in one of the workshops. So I'll see whether I can bring that concept of the light into it.
Well, I think it all starts with the difference between directions, because the light rays, as you said, it's 360 degrees, but it's a polar direction.
Yeah, we'll look at that later because we don't have time in this workshop to cover the whole subject matter that we need to cover here. It's just very basic. We have to keep things really basic here in the questions for now, John. But definitely we'll try to address that later. It's actually a very good question, but for more detail. Thank you.
Sorry for bringing this up. And well,
No, it's
No, it's good.
it's excellent. Like I say, it's just that we need to refer it to a later time where we can address it more properly.
fine.
It's more like a half an hour presentation.
You're
Just
one
a
of the
lot.
more advanced students, and we have to make this so that people from the public can,
Public can understand.
handle it easily and so on. Yeah. Okay.
So
Go ahead.
Jim, can we not view the magnetosphere of a plasma as somewhat of a demarcation between its internal fields and its external fields?
Another way to say the magnetosphere is the balance point between its magnetical and gravitational field strength.
The
So that's
word
that.
Coulomb barrier comes up a lot with Mr. Keshe
Yes.
in that
Yeah.
regard.
It's
And-
where the two fields balance. It's that point.
And it seems to me that the plasma has total control of everything internal to it, but then it gives off fields and it receives fields from its environment.
Yes. And that's the interaction that you get between two plasmas.
Right.
Thank you, Mark.
Sure.
Okay, we have another question here that came into YouTube chat. So do plasma rays actually travel in time, or does it actually take 0 time from point A to B?
Time is another one of those questions that's going to take hours to answer, because time is relevant to the environment we're in. So it's another whole conundrum. And based on the strength in which, Earth's environment has a certain strength, and space has a different strength. So all the different environments, light would travel at different speeds. And whether the light travels in its principal field strength or not. So that's another deeper discussion, and which we can't cover in the basics. So please keep your questions to what we've presented so that it helps other people to understand the work that has been put forward. Thank you.
Don't forget, today's episode is a part of a 12-part series about the basic understanding of the plasma. So there will be several subjects which will be coming soon.
Yes, as an example, we have a question in the live stream from Marin. If you create magnetic plasmoids, i.e. toroidal shape at a correct angle of alignment / coherence and polarization of one another, is there an anti-gravitational effect? And
There is no
I don't know if we have the time to answer that one today.
No, it's not related to the topic.
It's very easy. There is no such kind like anti-gravitation. Gravitation itself, it's created by the interaction of magnetic fields. So they have the same attraction or repulsion are just two kind of manifestations of the same phenomena.
And the Marin says, hello from Romania, by the way.
Yeah,
We
look, we
have-
understand there's a lot of people out there that have been studying for a long time, and so would have complicated questions, but this is not the place for those, because we're here to aim to try and keep this simple for the public to try and understand first.
Here's a simple question for you. Is there any link where we can download the slideshow of these teachings? Gunther asks in the live stream.
Yeah, we haven't sorted that one out yet as to where people can, but we will have those available soon.
And we had a Coco Marley. Hello, Coco. You can unmute and ask your question.
Hello.
Yes, hi.
Hi. Hi, everyone. I want to ask if the light that we see is the interaction of the field of the sun, and Earth. So the matter is what is the matter? I mean, the material that we have on Earth. So it's an interaction with the different length of the field, or what?
What we see as you call the matter, it's basically the fields that have slowed down enough that we can see them with our field strength, which is our eyes.
Okay.
And so we can see them. So everything is still a field, but it's just slowed down enough for us to see them. And that's what we see as the matter.
Okay. So what is the how can I say it? What is the small thing that made the difference between being a state in light state, let's say, or in the matter state, or transform as a stone, a mineral, or whatever?
It's when you change the different conditions, which means changing the environment with different environments of magnetic and gravitational fields. So it's whatever environment that field comes into and will manifest as matter or not.
So I'd say the shape of a plasma or an entity which is formed by plasma is determined by the balance of its internal magnetical gravitational forces, so attracting and repulsing forces, and the balance of its internal magnetical gravitational forces and the external gravitational magnetical forces of the environment, or call them fields or field forces, whatever you like.
Okay.
Additionally, we have a series of transitions, like from the element to the nano level, or the nano realm, you might say. And then from the nano to what we call the Gans realm, the Gans materials, which are closer to a plasma than to the matter level, which would be the element at the sort of the bottom of this scale. And then we go from the element, the nano, the Gans, and then into the plasma, or what's sometimes called plasma water, and so on. And then you can go further into plasma gases and whatnot. And finally, at the top, into being able to manipulate or work with these plasmas. So it's a full range with these different levels. And then it goes backwards the same way to create elements from plasma. So we start to understand the processes of running between the matter level and the plasma level. How does that work to go from one realm to the other, from one dimension to the other, essentially?
Another way to explain it, Rick, is if you look at the picture and the one on the left, that spiral. So it's essentially just a different field strength. If you look at the orange section, you get the green and you get the orange section, that would be the matter field strength. And as you work your way around, you get visible light, X-rays, gamma rays, and so the field strength varies. So depending on where you're wanting to work, and as you get towards the center of your spiral, you're getting obviously a stronger and stronger field strength. So we call it matter, we call it Gans, it's just a different field strength.
If I'd
Does
made,
that help?
if I would be allowed to start my video, I would show an example. Cannot start my video because the host has stopped it.
Sorry about that. Go ahead.
Okay, so what I said before, that the shape of an object is determined, or an entity is determined by the balance between its internal forces or fields and the external ones of the environment. So I have here such an object, you see, and let's change its internal conditions. We have external conditions, which is the air, the atmospheric pressure, okay? So this is just a parallel. I give to it a different force inside, so its shape is determined by the balance of its internal pressure and external pressure in case of this balloon. I can change that by increasing the internal forces, the internal pressure, or decreasing them. So what you see is the outer part, the outer shell, it is the balance of the internal and external conditions. I hope this makes it a bit easier to understand.
Yeah, thank you very much. Yeah, that's clear.
It's in a very simple way. With the fields, we have the issue that we cannot see all the fields. You see, we see fields of a certain strength, which you perceive as light. But we have a limited perception in the entire spectrum of all the fields. You have heard maybe that bees or dogs, they have a different vision than we have. But we have a very big common range, which is determined by the common amino acids from which our bodies are made of. So basically, we perceive those lights, those rays, and those fields which are within our sensitivity range. If you look at the sky, you see some stars in a clear night. What we see is just a part of what it is there out. There is much more to it. But those entities are out of the range of our perception. You have heard of ultraviolet light or infrared light, which are out of our visibility spectrum. They still exist. You see how you can get a skin color by exposing yourself to ultraviolet lights. So we know they exist, they make an effect, a visible effect, but we cannot see them. Doesn't mean they don't exist.
Yeah. So can we say that everything have to be every matter state is the representation, the manifestation of its physicality from in the origin of as origin light? Can we say that? And the matter have to be transformed again if you want to give it its original shape. It has to be light again. Can we see it like this?
It seems like a good segue into the next section about GANs, perhaps.
No. I would say
turning matter into light. We call them balls of light, the GANs sometimes.
I would say matter is simply just coalesced by the interaction of fields from two different entities. We have this, in our example, we have the sun giving off its fields, which interact with the fields of the earth in the core of the earth. And the core of the earth interacts with itself. It's its own plasma. Fields are coming out and emanate out and come back in and form the crust of the earth, just much like an eggshell is formed inside the chicken. It's the different fields that form the shell or the crust, interacting again with the energy from the sun. And our entire atmosphere of our Earth comes from the interaction of the fields from the sun. And starting, the first thing that's formed is the gas of nitrogen. And from nitrogen comes carbon and hydrogen and oxygen. And those are the COHN, the amino acid that forms life on this Earth. So actually life on this Earth comes from the interaction of the fields from the sun in our atmosphere. And as those elements pass down or filter down through the atmosphere, they actually get more dense, more dense, more dense. And then again, landing on the surface of the Earth, forming the crust. So the crust is formed from the outer and from the inner at the same time.
And the sun is
matter.
And the sun is in interaction of fields with the central sun of our galaxy. And the central sun of our galaxy is in interaction in terms of fields with the central sun of our universe. Central sun of our universe is in such a relationship and connection with the central sun of the unicos, which is the totality of the universes, the cosmos of the universes, because there are several universes like ours, similar ones.
Okay, okay, that's very clear. Thank you very much. Thank you all.
Yes, thank you. Thank you. Welcome.
Another way, if any of you've got chickens, which we have, and when speaking of the egg, when you first see a chicken that's laid an egg, as the egg comes out, that shell is soft, but because it's now come from the environment or different condition within the chicken, and as soon as it hits the atmosphere, which is now a totally different environment, that egg hardens up. So because it's that change of environments. Within the chicken, it was soft. When out the chicken, it's now hard. So it's the same thing. It's just a different environment.
Okay, I got it.
And I noticed that Kevin Devani has some good words of advice. Simply read Keshe's book, The Structure of the Light.
Yes.
And that is a good, really good advice, actually. All of Keshe's books, they sometimes they're hard to get through with some of the way they're worded and so on. It's new ideas for us, but at the same time, each one has gems inside that are amazing and wonderful to take in.
For those that really wanting to get a handle on this technology, I certainly advise getting those books. I think they should be available soon again, because they become your textbook. I know myself, I've probably read them 5 or 10 times, but every time I read them, it's like reading a new book, because your understanding is so much more. And so when you read it, you understand more. So they are fantastic sources. All right. So now we go to the next part, which is GANs. And in here, we're going to go through the process of making CO2 GANs and zinc GANs. Now for zinc GANs, there is another method. This is just going to be the one method. So we will be doing another method in further workshops. And I'll go through the presentation, and then during that, I'll ask Sando if he'd like to add in what he can. And then when we get to question time, then I'll hand you over to Lisa, because she makes all our GANSs here. So she's would be able to answer a lot more questions than what I could. Okay. So what is the GANS? Definition, it's a new state of matter, a molecule of a gas, which becomes nano of itself and appears as a solid state of matter. So that's where we get the short term of GANS from.
So here, maybe some people would need to understand all the words, like what does it mean, nano?
Well, hopefully they've watched the previous 4, Sando.
Okay, so just a short rehearsal, because gas we used to understand. We have gases, solids, we have liquids, such a states of matter. And what does it mean, nano? Nano comes from nanometers, which is a dimension. It is a size or a dimension of the range comparable to the size of the atoms. That's its all meaning of nano. So I just like to clarify possible confusions about a not misunderstood word or a not understood word.
Okay, perfect. Thank you.
I would like to add something to what he just said. Mr. Keshe has explained nano in this case to mean individuality. So it may be that size, the dimension Sander says, which is 1 billionth of a meter. But then in cases of GANs, the emphasis is on individuality. Let's say, for example, of CO2, you have a carbon and 2 oxygens. Now, when they are COO, when they are individual, that should be noted here. That's all I had to add. Thank you very much. This is Gatwa.
Thanks, Gatwa.
So we are talking of entities which are the size of nanometers.
Sure, I understand that. It's 1 billionth of a meter.
Yeah.
But individuality is very important so that you don't confuse into molecules. People don't see CO2 as a molecule, but here is the C is individual and the oxygens are individual. So individuality is very important in this case.
Yes, thank you very much.
That's my understanding. Thank you.
Thank you, Dr. Gato.
Sure.
All right, so we've learned over the last few workshops. So we have the matter state, we've learned how to create the nano, and now from the nano, where we've nano coated our plates, we can now use all these to start creating our GANs material that we would like. And then from the GANs, we learn about the fields that come off from that GANs, as we've understood that the tiny little GANs that we produce is like the little suns. So it's like a little sun having its own magnetic or gravitational field. Right, so now we'll go on to the creation of CO2 GANs. And the plants all around us are doing this all the time through their leaves. So it's nothing new. It's just something that we've never understood. And now we can also produce our own CO2 GANs. We've got to look at each leaf as a CO2 reactor. So the leaves are creating that CO2 internally. Just like we create the amino acids on the surface of the water, so the leaves create amino acids on the top surface of their leaf. And the shiny layers on all the leaves is your amino acids. So we'll explain that as we go on. So in the fourth workshop, we showed you the different leaf structures, different shapes. And so what this means is that each leaf will be creating a different field strength of that CO2 internally, because the conditions have changed. And we're meaning that the conditions have changed, it's just the different shape of that leaf.
Jim?
Yeah.
Okay. I guess one big question that comes to my mind is if you can do a general overview or general look at what is CO2 GANs and zinc GANs, and why would you ever want to make them?
I will be asking, and Dr. Rodrigo will be covering that next week, because it's mainly related to huge benefits on health aspects. And next week we'll also be doing how it's useful for agriculture. So we'll be going into the uses of it in the next workshops.
Okay.
Here we just focus on how to make it.
Thank you.
Okay. All right, so what you're going to be needing is your zinc plate, your nano-coated copper plate, a plastic box, green LED light, copper wire, some distilled water or seawater, and pure sea salt if you're using some distilled water. So I ended off last session about showing this picture about the leaf, whether anybody went outside and noticed that your leaf has sort of that shiny side and underneath has that matte side. So all we're going to be doing is replicating that leaf. Because if we had to view that your nano layered copper plate, now please ensure that when you take your nano plate, as we explained last time, when you make your nano layers, is to please wash your plate very well to remove any of your residue caustic soda that you might have left on that plate. But the nano layer is sort of the same as your shiny side of the leaf, which is also nano layered. And the zinc plate is needed as well. This forms the other side of the leaf structure. So your two plates that you've got are representing the two sides of the leaf. And what this does is it creates a magnetical and gravitational condition around the leaf, which is equal to the mag-grav field strength of CO2 in the environment. So your leaf is creating the condition to attract the fields of CO2 into the leaf structure. So we're going to do the same. So we take your box, and on the one side you've got your zinc plate, and the other side you'd have your nano-layered copper plate. And when you position them opposite each other like that, you're creating the same conditions as the leaf, and you create the same magnetical gravitational condition to start attracting and creating your CO2. Now, in between, when you look at within your leaf, there's different compositions there of water and different amounts and solutions of salt within that leaf, very trace amounts, but they are still there. And so we have to do the same. So within that box, once you've set up your plates, we add the salt water into our container, just as like the leaf. So if we're close to the beach, we can use the seawater, or you make your own solution with distilled water, and you could use between 3.5% to 10% of sea salt. I know the ocean water will vary with your salt concentrations of around 4.5% to 5.5%, depending on where you are in the world. And some people have had some success with varying the concentrations of salt in producing their CO2. And to get your solution, for an example here, if you're wanting a 3.5% solution in your water, then you just add 35 grams of your sea salt in 1,000 milliliters of distilled water, and that will give you your 3.5% solution. So once you've position those plates in your box with your water, please ensure that your plates are also hanging in the water and not resting on the bottom of the container. Now, it's important to understand that your nano copper plate that you've created, that this plate creates and controls the condition in your box, because you've created those nano layers, the field from that material crosses this whole area between your two plates and creates that condition within your box. So what we've created is the same as the leaf, and we've got our two plates within the salt water, and this creates the magnetical and gravitational field that is the same as the CO2 to attract. What we need to do next is to connect the two plates with a wire to create a flow. But we have to control the current flow between the two plates. So what one has to do is to connect a LED light, a red or a green light, between the two wires, and so that this LED acts as a resistance or load to the flow of the current, because we need to slow that current flow down. And so we do that with an LED. Okay, so now we just got to look at understanding why we're using these particular metal plates. So when we have a look at the atomic mass of zinc, it's around 65. And the atomic mass of copper is around 63. You look on the periodic tables. But when we nano layer the copper plate, we reduce that to less 5%. So we reduce that to around 59. So when we have a look at the difference between the zinc plate and your nano layered copper, we have a difference of 6. So what we have done is we've now created a gravitational field strength difference of 6. So when we look at carbon, it has 6 neutrons, 6 protons, and 6 electrons. So we need 50% of the fields, the 6 neutrons, to attract the rest. There's also a portion of graphene or carbon on the layers of your nanocoating, which also gives the plasmatic energy of carbon. So what we're doing is creating and dictating an environment between the two plates of carbon, so that the carbon interacts with the oxygen in the water to create our CO2. So essentially we have the setup the same as the leaf. We have the zinc plate and your nano copper plate, and you have your LED to control and slow that flow between the two. So what you've created is you've created an environment between the two plates, which creates the magnetic gravitational field strength to attract the carbon into that area. And when the carbon comes into contact with the water, it oxidizes to form our CO2. So when we have the LED or that load between the plates, we will be producing around 85% of CO2 and around 15% of zinc oxide. You'll never get a pure CO2 unless we actually seal off the two plates. So we're always going to create a combination here of CO2 and zinc oxide in the water. But this method will definitely give you around 85% of the CO2. So what happens is when you get your box going, is you start creating a field environment around the box, and this grows over time. And because we've now started creating a small amount of CO2 in our box, this also begins to attract CO2 from the environment because it acts as sort of a magnet in the box. So we can also start attracting CO2 to clean up the environment. And we also attract a lot of the carbons, oxygens, hydrogens, and nitrogens, which form the amino acids on the surface of the water. Because what you'll find is after 2 or 3 or a couple of weeks, when you let your setup run, is that you will start seeing a bit of a shiny, oily layer on the surface of your water. And that is essentially the amino acids which collect on the surface of the water. So when we look at the whole environment around our box, you can see that we initially created the condition to attract the carbon. And then as the CO2 is formed in the box, we then also create that condition to attract further CO2, but we're also attracting the carbon, hydrogen, oxygen, nitrogen, which forms the amino acids. So what we're doing is creating a huge environment around our box, which is creating that condition to attract those elements in. And then over time, you'll see that you'll notice a creamy white fluffy powder which forms on the bottom of your container, and that is your CO2 Gans. And there will be many ways to extract this. One of them is to extract the CO2 Gans with a syringe. So you just soak up the bottom Gans from the bottom, and you place that into a separate container. So now once you've extracted all your CO2 from the bottom of your box and put that into a separate container, we now need to start washing that Gans, because that would contain quite a bit of still salt in that solution. And so what we'll do is we'll just add distilled water to the Gans and then allow this to settle, because it will just puff up your Gans within that water. So we just allow, sometimes it can take 6-12 hours for that to really settle down to the bottom. And then you can just carefully pour off the top of that water so that not to pour away some of your Gans material. And then you just refill that again with distilled water. So you just wash and wash many times to ensure that you've washed all your salt out. What we found is that by placing your Gans into a bigger container, you're able to pour in a lot more amount of distilled water in there to start doing the cleaning process. So this way you ensure you get rid of your salt out of the water. And the best way is just to do a taste test to see if you taste any salt that still might be left in your water. If you do, then just continue washing until there is no taste. Collecting your amino acids, say after a few weeks, you'll notice that there's like a shiny, oily layer on the top of your water. That's the amino acids. So the best way to do it is just to take a plastic spoon and scoop this oil off carefully and place it into a separate jar. And this you don't need to wash, because it's the amino acids need to be sort of stored in a little bit of a salt solution. So it's just a case of scooping off that oil and placing that into a separate jar. And that would be then your amino acids with the field strength of the CO2. So once you've washed and collected, then you're left with your CO2 Gans, which you just keep in a separate bottle with distilled water so that it's ready for use when you need it. So you can see what we've done is we've essentially started creating a material from the fields around us, because we created the condition within the box to attract the field strength of carbon, which comes in and interacts to create the CO2. So even the simple process of creating the CO2 is using and interacting with the fields around us that we just don't see. So even on the simple process we've begun. And then from our CO2, we can start the process to create the matter that we would eventually create and want. So troubleshooting, one can adjust the distance between the plates, between the zinc and the nanocopper plate. If you find you're not producing any CO2, one can also vary that salt concentration. And very importantly, we do not add any form of power supply or battery to this setup at all. And another way to confirm that you also have the CO2 Gans is to place some in the freezer, as the Gans does not freeze. Now, the question that comes up to mind is what happens if we do not control the flow between the two plates? So if we have no LED to control that, no load between the two wires, what are we going to then produce? And essentially, we then end up creating zinc oxide Gans. So without that LED or without any load between the two wires, it leads to a high current flow between the two plates. And so this results in more the formation of zinc oxide than CO2. So in this process, we're creating Gans material at the bottom of the container, which is probably around 90–95% of zinc oxide and only 5 to 10% of your CO2. As I said before, this is just one of the methods to make the zinc. We will look at other ways to make your zinc Gans. But this one's very important to understand because we have seen a lot of people out there that are creating and showing that they're creating huge amounts of CO2 Gans, what they would view as CO2 Gans. But when you look at their setup, they don't have any load across there, or they've put batteries between the two plates. And so essentially what they're creating is 90%, 95% of zinc oxide and very little of the CO2. There's nothing wrong with that because zinc has its uses, but it's just a case of one needs to know what you are wanting to produce and what you are creating. So it's very important to understand how you set your box up. And as you've seen, if we change that condition, we get something entirely different. So just the aspect of putting a load or not putting a load, we know whether we're creating mainly CO2 or whether we're creating mainly zinc Gans. So any little change that you make in your box is going to change the outcome of what you're producing. And here's a photograph of, and you can tell the difference. You can see clearly that there is a difference between the CO2 Gans that we've produced, and then which is on the left, and then your zinc oxide Gans on the right. The CO2 Gans always seems to have a creamier color, whereas your zinc oxide is very, very white. And then as we begin to understand with all our processes it's our intention when we're creating the Gans that's important. It's how you feel, it's your emotions at the time of setting up your Gans will have an impact on the outcome. It's what you want to create your Gans for, if it's for helping people, helping the environment. So it's your intentions that you set when you're wanting to create your Gans. because we understand our thoughts and our energies have maggrav fields which will be transferred into the box and our GANS materials that we are making. So you need to set your intentions very clearly when you set up any device where you're making nanomaterials or GANS materials, whenever we're working with any plasma devices. And more information on CO2 production, one can go to the KF Wiki there as well. So I know we're going to have quite a few questions. So I'm going to hand you over to Lisa, and Sander will be there as well to answer many questions.
Okay, there are a few coming in here, yes. Hello, Nicholas. What's your question?
Good morning. I have several, 2 or 3 questions, and I hope they're completely basic. Let's start out in the beginning. We're using a LED light. The question is, why green?
Sandor, have you got the answer to that? Because I'm not too sure.
Can you repeat the question, please?
It was why is it a green LED or a green or red LED?
It was empirically found that it works, but practically you can use any LED. If you have no LED, use something else to reduce the current. Just put a load which reduces the currents. So if you have no LED at all, you can improvise such a load from anything with a high resistance. For instance, if I may start my video. Just a second. Just a second. So here is an improvised CO2 kit, with a piece of zinc taken out from battery. Here is some nano-coated wires, and I made a connection with some thin telephone wires. And in order to provide here a load, I just took a raw twig without its bark. So a fresh twig cut from a tree, which is slightly wet. It has some moisture. So it allows a little current, a very little current to go through. Something milliamps or microamps or nanoamps, it's enough for making GANS. And in order to keep this twig from drying, to keep it moist, I put here a piece of cloth, which I let to hang into the water, so it absorbs some humidity and it keeps the middle of this twig always wet. So later you have to change it if it dries or whatever thing might happen with it. But you can even improvise such a simple thing to reduce the current. But LED, it's at hand, it's common component which costs pennies, and you can use that. It's essential to put something in between the two metal plates, which reduces the current.
Shandor, what about nano-coated wire and twisting them together from each plate? Is that acceptable?
If the nano coating is good, so I used in the past very much, just 2 nano coated wires which are twisted together. And I could verify with ohmmeter that it had a resistance of the order of tens of megohms. So it also works.
Although I seem to get quite a lot of zinc when I do that, Sandor. Maybe my nano coating isn't good enough.
So how you determine the content of zinc and the content of CO2?
You
Can
can
you make
literally
some
see,
analysis?
you can literally see a bit of the like almost bubbling at the side of the zinc.
Bubbling?
If it, well, it's coming off, so you can see that there's action on the zinc side, the zinc plate side, in a sense.
And where do you expect the action to happen?
Nowhere. When it's CO2, the action shouldn't happen anywhere. It happens so slowly that you don't you don't see, because there seem to be flakes on generally the whole of the box. Whereas if you've got current running, you'll see that it'll collect on the under the zinc plate, which is then the zinc.
So I'm back again. Let's go to this wire. So the idea of connecting the two plates with a wire and an LED between is very simple. Now we're going back and forth with the question of nanocoating and not nanocoating. In the beginning, when we started making GANs, the instructions were that you would have two wires coming from your plate. Didn't need to be nanocoated. They were wires that had a plastic cover like electrical wires exposed in both ends. One end connected to your nanocoated plate and the other connected to your LED light.
The question is, what was the beginning for you? Because I remember in the beginnings of the beginnings, when Spaceship Institute was in North Italy, at the Senzano del Garda, we had no such many teachings, public teachings, but we had some. Then we have seen how the knowledge seekers were making the GANs collection kits, and they connected together many boxes, wired from one to the next, to the next, to the next, and at the end, always it was closed with an LED or with a small motor of a fan or some load. So from the beginning, we have been told to use something like that.
I see the beginning kind of as a wiki. So
you started to begin with KF Wiki. So KF Wiki, it's made as a volunteer work for knowledge seekers, put together some essentials, and maybe some little parts were missing, and always a Wikipedia, it's a work in progress. So always people observe what it is there, and they add something or they adjust it a little bit.
Nonetheless, the wikis are point of reference. And so let's get back to my question.
It's a summarized point of reference, but it's not substitute for the teachings. It's just like a reminder, a summarization.
Well, thank you for that. So let's get back to the basic question. What kind of wire do we connect? What kind of wire do we use?
If you have an LED in the middle, you can use any kind of wire.
Yeah, I've tried every single wire under the sun, and they all work the same, really.
Well, very good. Thank you.
Just a second. Let me share something.
Any kind of wire, does that mean any kind of wire, or does that mean copper wire?
Yes.
Yes, copper wire.
We had a knowledge seeker from Romania, Mr. David Berianu, who made some time-lapse video. So he took a picture at every 20 seconds, and then he edited them together as 25 frames per second. And watch here what happens between the nano-coated plate on the right and the zinc plate on the left. Watch there, the particles. So this is a slow motion. You cannot observe in real time, only if you make such a time-lapse video. So see the motion of the GANs. So you can see the all kind of live motions like vortexes and flows. You can see here on the top part, which is spinning. It's very interesting. And now the white spots are just the reflections of the LED light, which he used for the purpose of making the photo in certain light conditions. And what is interesting, he made a second video with another kit. And the difference between the two kits was that in one of the cases, he used a fresh, brand new plastic box. And there he just observed that the Gans it's created on the plate and it falls down vertically. But the other box was nano coated previously, so it's the box which he used to make the nano coating by caustic. So the walls of the box themselves became nano coated. So inside there is a more or less closed plasmatic environment. That nano coating makes a little barrier. So the fields are constrained in the space. And we could see this beautiful motion. This beautiful.
So are you saying that we should nanocoat our CO2 box before we use it?
It is very much recommendable to do that. It's not a must, but it is very, very, very highly recommended.
Oh, that's excellent. I love it.
Yeah. So anyway, you will make some nano coating for the copper. So in the same process, you can nano coat your boxes which you are going to use.
Another really good suggestion, what I normally do is once I've used my box, I label it a CO2 box, and it is always a CO2 box. Don't try and make other ganses in there. And I don't scrub my boxes. I leave, if there's a little bit of residue there, I usually leave it and then just refill with the next batch of water and continue, because then it tends to pull in more Gans at a faster pace, because it's already got minute particles of Gans ready there.
Yes, thank you very much, Lisa, for that. This is again important. Once you created a plasma in a box with your metal plates, even if you remove the water, you remove the plates, there will be some plasma of a specific strength which will stay there. So we have heard stories of people who made copper oxide Gans, and later they tried to make a CO2 Gans in the same box. After they scrubbed it, they washed it, and it was still producing some green color Gans because they still had the fields inside.
Can you neutralize that by re-nanocoating it, putting caustic in it, vinegar or anything like that?
I tried with vinegar, and still it didn't change much. So it's good if you started to use a box for a purpose, then keep it for that. And I remember the teachings of my grandmother, and my grandmother also. She had such a wooden spoons for making food, and which spoon touched one's onion, it was used only for stews and sauces with onion. If she had another one only for sweets or milk, or for rice boiled in milk, or such a thing without, or for creams, for cakes, that was again special, because however you wash it, still some odors remain. Also, if you wash your used jars, if you have a jar which had pickled cucumbers, for instance, and you had another which had let's say a blackberry jam, you wash them very well at high temperature, and if you leave a top on them, after 1 year, you open the top and you smell in, you will find by the odor which was used for what. Some fields will always remain in the containers, whatever you do with them. So it's good to have dedicated one box for CO2, other for CH3, and so on.
So a number of us now have boxes that since we didn't have this knowledge, before we have a whole lot of boxes in our lab that we've done different things with. So my question would be, do we discard all those boxes or do we re-nanocoat them with caustic? Would that neutralize to a certain degree? I'm
I
hearing
don't
you.
know if you can neutralize that. I have no such knowledge. I prefer to use a
So what
clean.
are you saying? We're saying throw away all these boxes and start over?
Don't
I
throw
mean,
them out, wash them well and use them to keep your bolts and nuts or whatever you need in your garage.
Or have you seen, you know, Mr. Keshe has suggested people can also start looking at trying different composites that you put like a different plate on each side of the box. So you would do 4 different plates, etc., and start seeing what you're getting. So use them to play a little bit and see what you get.
Yeah, but if you want to control what you will get, you have to know what kind of fields are in that environment. If you have forgotten what for you use the box and what was inside, it's very hard to be sure about.
Maybe, Shandor, you could explain briefly the idea of the box with the copper and the zinc and the balance of the plasmatic fields between the two differences in potentials and so on. Or maybe that's in too much depth for now. Or...
Yeah, it was in a presentation, but rehash or rehearsal doesn't. It's always useful. So you have your box, which is preferably to be nano-coated to keep the fields inside. So if you make a hot caustic process inside, also the plastic, which is made mainly of carbon and hydrogen bonds in a specific way, still you will get kind of nano layers, which are very thin. It's not visible to your eyes, but they are suitable to produce some closure for the fields. Then we use the inside, we use such a zinc plate, and we use a sorry, let me change that color. Oops. You have the nano-coated copper plate. Then you have your saltwater environment. You have here water and sodium chloride. And then you have your connections. And let's say you use an LED for reducing the currents. So what happens here? Once when you put the two metals, a different kind, into a salt environment, into salt water, you will find that there will be a little voltage in between. And this little voltage used to be some 0.5 volts up to 0.9 volts. It depends on the quality of your nano coating and the concentration of salt. But anyway, it will appear the voltage here. So you will get some electric current, which will go through the wires on the top and inside through the ions of the water. So you will get a current here. So if this current is not limited by the LED or other load which is in the circuit, in that case, this current will have a stronger effect to dislocate such particles of zinc, which will tend to travel to the copper. And on their way, they will combine with the oxygen ions from the water, and it will create some kind of zinc oxide. So this is why you get zinc. Now let's go back to the basic condition without these currents. What happens in plasmatic terms? If you have a copper in a metallic bond, you have the atoms in a tight connection. They are very tight, they are very close each to the other. So they do not emit too much fields around. The fields are mainly inside. So when you make a nanostate, a nanolayer, what you will get, these atoms will get at a higher energy level, and they create a bigger spacing in between, while there is the interaction of the fields of attraction and repulsion repulsion between them. So they get a little more space. And implicitly, such a nanolayers will emit into the space more fields. So you'll have here fields all around, which are coming from this nano-coated copper plate. So this is what makes the magic. The fields created by these nanolayers. So now we need to evaluate or to measure the strength of the fields. So a good indicator is the mass number, not the atomic number, but the mass number, or atomic weight, in other terms, or molecular weight, or and so on. You get this mass number from the periodic table of elements. It's the number with a bigger value. In case of copper, it says it's a 64. Actually, it's copper as a metal. Actually, copper is made of different isotopes of copper. What does it mean, isotope? Iso, it means uniform, and topos in all the language, Greek, Old Greek means position, location. It means isotopes are the elements which are located into the same box in the periodic table. And that's made based on the number of protons. So isotopes have always the same number of protons for an element, but the number of neutrons is different. So in case of copper, it is in nature never copper 64, but it's a mixture of isotope 63. So the number of its electrons and the protons added together is 63. And you have another part of the composition of the copper from nature as a metal, which is isotope 65. Usually we have about 69% or 71% of isotope 63, and the remaining 29% is isotope 65. What you see in the periodic table of elements as 64 is just an average number. So in your copper plate, there is no isotope 64. It's a mixture of isotope 63 and 65. So you have to understand that you are working with a spectrum, with a range of field strengths. It's never fine-tuned only to one. And we have learned from the previous lessons that when you have two fields or two magnetic arrays of the same or near similar strength, in that case, these will get entangled, and they start to interact each with other. So this is the reason why these isotope 63 and 65 are hold together, because they have a near strength. So now when we go on a nanostate, the a number of the neutrons will get the magnetical and gravitational fields got in balance. So all will lose from its mass number. So in case of a nanomaterial, we have such a strength, something between 58 and let's say 60. We say an average of 59. So this is needed to understand why we use this figure. So in case of the nano copper plate, we have a field strength here around, which is a field strength of around 59. But in the same time, we have some fields of the zinc plate which do not extend so much in the space, but still they exist. And zinc has an average field strength of 65. Actually, it goes from 62 to 70 because zinc in nature, it's a mixture of 5 isotopes. You can look up in Wikipedia for the article Isotopes of Zinc and you will learn more. But we use these two figures, these two numbers for the field strength. So here we have a field of 59, which is filtered by a field of 65 in this plasmatic condition. So if these will interact, what will be the strength of the leftover fields, which will be free? So 59 will interact with 59 out of 65. They'll get in a balance. And they will be left a difference of these two, which is equal of 6 or around 6 because of the isotopes. It's a plus minus of some numbers. So from these fields, we will get field strength of 6, which will manifest itself here. And if you look at the periodic table of elements, we find that carbon has 6 protons, 6 neutrons, and 6 electrons. So this field strength of 6 will pull the fields of the 6 protons of the carbon. And if you pull its protons, its neutrons will come too. Like if you pull somebody by his left hand, probably his other hand and his body and his feet will come too. Is it so? So what we create here, it's a condition of fields which manifest an attraction of a field strength of 6 or around 6. So we pull from the environment plasmatic fields of the value of the carbon. So carbon comes here in between. Now, because we have here this salt water condition, salt will allow the manifestation of those fields in a matter form. So you'll get there that carbon. Meanwhile, the water contains that oxygen here, and that oxygen will combine with the carbon, and so you will get a CO2 in form of Gans, which goes down. Of course, in the same time, you have also other conditions that zinc also gets into that water. I explained before, because of this electric currents, and also because of the field attraction, because 59 of the copper, it's near enough to 65 of the zinc, so it will also pull the fields of the zinc too. So that's why what you will get here in a Gans will be a mixture of Gans of CO2, Gans of zinc oxide, and probably some CO2 and zinc will combine and you will get a zinc carbonate or whatever. So from chemical viewpoint, you will have a mixture of a pure element. Now, by adjusting the conditions, you can refine this a little bit better. For instance, if you don't want zinc to get into the composition, you may try to get a plastic bag. I marked it with green. You put in a thin plastic bag the zinc plate, and you have to find the right salinity and the right distance between the plates to still have the interaction, because now it's filtered also through the plastic, but that thin plastic will not allow the zinc to dissolve into the water. So in that case, you will get less zinc oxide and more CO2. Another way, if you want to get any copper which may dissolve into the salt water, you can try to do, just a second, let me clear this. You can try to put your nano-coated copper plate outside of your container of water, or try to nano-coat the zinc also to strengthen its fields, and to put outside of the box that one. But these are the things which you can experiment and bring further those principles which you learn here. So I hope you understand about why the difference of the fields, of which at least one, it's a strong field which goes deeper in space. You can feel it at meters, which comes from the nano-coated surface. Why this difference of fields manifest to certain conditions? So let me add some. Yes.
Well, you answered the question that Herbert had in the chat here regarding the flow of the plasma and the plates and so on. He mentions that was just answered by Shandor, and as well as in the live stream, there was a question about dimensions of electrodes and the current and so on. He says it's no longer the case. I understand, and thank you. So
here the purpose is to reduce this current to be of the order of milliamps or microamps or nanoamps. To understand the importance of these currents, so look at the living bodies, plants, animals, the body of man, for instance. You know, from labor safety teachings, that a current of 3-4 milliamperes can cause the fibrillation of the heart. So milliamperes are already too high for the living bodies. And here we replicate processes which are in living bodies, like in the living leaves. So we have to go to currents of the orders of microamps and eventually to nanoamps.
And this is why it takes a long time to make the CO2, and people must be aware that you must have your boxes going for a long time to get a reasonable amount of CO2. It doesn't come off in a few hours.
So yes,
how much is a long time?
It depends of your patience.
My boxes
some
go
people
for
5 minutes is long, for
months.
some 5 weeks is fine. So allow at least 1 week. Of course, as soon as you make your CO2 kit, if you made it proper, you have a lot of GANs in the first hour. But understand that that may be mainly such as zinc GANs of zinc.
And it depends, Sandor, where you live, because we live out in a rural area, in a sort of almost like a foresty position, and we only a few in the house, and the air is very clean. So we get very little CO2 floating about, and so our CO2 production is very sparse. And Mr. Keshe has already told me to go and stick my CO2 box in the hen house with all the chickens to breathe on it, but I don't think I will because I don't want chicken poo in there either. But so if you're in a dirty city, it actually helps.
Yeah, and by the way, you know, those soda bottles, they were in a fashion in the 70s, maybe in the 80s. But
Yeah, I remember those.
Still you
Gold
can buy
ones.
those carbon dioxide cartridges. So if you manage to take only the gas from it and to let that gas to go here in the middle, for instance, you have a small disperser, porous disperser like for fish tanks, to allow a stream of carbon dioxide, probably you can accelerate the process. And of course, it's different if you are on the top of a high mountain and in that fresh air on Himalayas, and where you have very little CO2. And if you are in a huge city like Beijing, for instance, where you have too much CO2.
Mr. Keshe has also explained that your isotopes of the CO2 can be different in different places of the world. So your C6 might be different. You might have a C9 sitting, you know, on certain places on the planet. So you might not pull in as much as what somebody who's got this correct CO2 isotopes in their area.
So absolutely. So probably you will have a different kind of CO2 from a oak tree and a different one from a palm tree.
Yeah, what people must realize is if they make a lot of CO2, and I took this on board very early with Mr. Keshe saying that you need many field strengths of the CO2 to connect with the body. And so every time I make CO2, I put the new batch in with all my older batches and I create a soup pot of CO2. And so that it's got many fields that you've created over many different seasons and, you know, the different heat of the day and cool and what have you. And that all adds to the different field strengths, which helps to connect it to the body.
Yeah. Yes, sure.
What about covering the CO2 box to protect it from dirt or dust?
If you think to cover it with a sieve, which allows the air to go through.
A sieve or a cloth.
You know those old voile curtains that we used to all hang in the 80s or something like that. You know.
So, probably you don't want to cover it fully, because if you cover it with a top, with a lid, so how you expect the carbon to get in? But you can get such a thin sieve. Oh, let me stop that virtual.
You're saying a paper towel.
No, something fine, like a mesh, like
This is a fine mesh, for instance. Can you, so maybe I can focus on it.
Like a fine fabric.
With a mesh or with a sieve, but don't cover it with a solid top. Otherwise, you will not get the fields inside.
Yes, thank you, Sander.
You're welcome.
So another basic question would be, when you're using seawater, do you strain it? How do you prepare the seawater to use it?
Attention, do not use seawater for making your GANs, period. Because seawater contains all the elements of this earth, wanted or not wanted. Think about the pollution. How many mercury containing batteries reached into the sea? How much depleted uranium
So wait a minute,
have fallen into the Balkanian war into the Adriatic Sea?
Shandor, are you saying people should not use sea salt then for their
sea salt is different. Sea salt is different. There are so many products which are marketed as sea salt. There are plenty of products which are marketed as sea salt. But what kind of sea salt is that? Because from sea salt, where they have for instance, in Near East, we have a huge salty lake, which is called the Dead Sea. It's a concentrated salt. It contains everything, of course. And there is a local business to remove the salt, to exploit the salt out of it. And what's the most precious salt? The salt which is used for food. So in the process of evaporating the water from the salt, first of all, they separate the sodium chloride and they obtain 95 or 99.5% purity sodium chloride, and it's labeled sea salt, but it's for food. And the leftovers are also called sea salt, but they contain less than 4% sodium chloride, and they contain huge quantities of magnesium sulfate, magnesium bromide, potassium chloride, and many other kind of salts. And those are not for human consumption. They are used for a spa, for a bath. You put that salt in the water in which you make baths. They say it's good for your skin. I don't know if it's good at all, but they say it and they can sell it with a good promotion.
Yeah, this makes sense.
The sea salt, and you don't know what it is. Or you have the sea salt Guérande style from France. Usually in Europe, it's in Auchan supermarkets, is available, which is a raw, unrefined salt from the Atlantic Ocean, and it contains everything, including some mud and foam and others.
Well, if you go into the supermarket, you have choices of sea salt. There's Mediterranean sea salt. There's Italian sea salt. There's
it does not matter the provenience. That's just
all,
marketing. It contains, it's important the chemical composition.
They're pure sea salt, though. Should people not use these products? What are you suggesting?
You can use any kind of salt, and don't forget the mine salt. The rock salt is also a sea salt, but from the seas from millions of years ago.
So it may be less polluted, perhaps.
Just a second. I'd like to find something to share.
Just trying to establish this because it was a question earlier with Nick came up with Flint, and we were discussing about how to approach it and so on. Whether to use definitely people should not use seawater and put the caustic in and try to make GANs that way. And that's something, people make the so-called ormus and so on and say they can make CO2 Gans and zinc Gans out of that process and make tons of it and so on and so forth.
Thank you for bringing that up. That's
very dangerous to do. But that's different than what we're talking about with this kit. But maybe you could talk about that a little bit.
Yeah,
I'd like to refer it back to this discussion here, which is, can we use seawater? You say no, but then we can use sea salt that comes from the seawater. So
let me show you something. Let me show you something to conclude about the salt. So the thing which what the salt is made of, it's a laboratory certificate of analysis for a salt which you purchased. It has a lot number. It has a test date or retest date. It's one production lot. And you see the content, sodium chloride. Specification says it should be at least 99.5%, and the result of analysis says 99.97%. It's excellent. And it has then the values for the other trace elements. So this is that allows you to know what you have in the salt if the trader can provide you a certificate of analysis. Because in the salts which you buy, there are so many additives, and in some salts contain high quantities of other things. For instance, in some salts in Europe, I found about 20 up to 30% quartz or glass, which is not soluble. So you don't want those to be inside. And the term of sea salt, it's a marketing term. It doesn't say the composition.
That's why people should actually filter the saltwater solution through a coffee filter or something like that first to take out any larger parts that don't dissolve. Is that
okay? So, filtering, and so you make your solution. Something will go, some mud will go to the bottom, and you will have something floating on the top. So then you stream it through a paper filter, which is used for making coffee in German style, and you have it a cleaner solution. So the purer are the materials we use.
Is the bottom line is that we can use sea salt to make these solutions, but you have to know what your source is, and you have to know what's in it. Basically, that's the idea. Not just use any sea salt. Some of them may have higher concentrations of things we don't want in there. And if you're using seawater, you wouldn't want to take it from most shores of our industrialized areas. Okay.
This is a composition of a so-called sea salt, but this is not for consumption. Potassium chloride, 21–23%. Sodium chloride, 4 to 6%. Magnesium chloride, 30–32%. Calcium chloride, 0.4–0.65%. Water, 37–40%. Magnesium bromide, 0.2–0.6%. So it has its.
Where does that come from?
I think from Jordan. This is a spa salt for.
Oh, spa salt. Okay.
Spa salt from the Dead Sea, but it's a sea salt. The same company sells a pure 99.5% purity sodium chloride also as a sea salt. So what they got from the sea, they separate it and they market it in different packings for different purposes. Yeah. So if you buy just sea salt and you don't know what kind of sea salt, you get in big confusions.
Probably it's a good idea not to use the bath salts in general, eh?
No, this is that sel de Guérande. This is another salt. Somewhere it has a composition. Just let me find. No, it doesn't even have, so I have to trace it in other part. So this is a unpurified natural gray salt obtained by traditional procedure from the ocean. So they have on the shore such a basins for salt, they evaporate it, and this is how it looks like. Again, it's a mixture of many things.
Just to put one little, I suppose, stirrer in the pot here. If you look at the composition of seawater and the composition of blood, they are very similar. And in the early 20th century, they used to clean seawater and actually use it as blood transfusion. So it is very compatible in a sense. So we don't need to get too stressed out about.
Yes, before the many nuclear experiments which man did. And not after.
Just saying that most of the things there are compatible with the human body, not necessarily the nuclear bits.
When I was a kid, I could drink directly from some rivers without having any problem. Not today. And all the rivers go into the seas and oceans. Don't forget that. Now back to the subject which Rick told about the Ormus and the way of making the so-called Gans from seawater with caustic. So what happens? First of all, I have to say that Gans is not Ormus. Ormus, it's a coined term. Originally it was Orme, which was meaning orbitally rearranged monatomic elements. So monoatomic, it means a single kind of atom and not two kind of atoms. So when we talk of zinc oxide and CO2, they are not monatomic. So you understand it's something completely different. It was a scientist who came up with the idea that he's producing a new form of matter state, which is called the monatomic element, and that he called Orme, and later it was called Ormus. He patented a procedure for extracting those monatomic elements from the seawater. But the procedure is complex. It requires special laboratory tools and huge quantities of ocean water or seawater to extract such a milligrams of such so-called Ormus. Unfortunately, people who like to copy and paste and to make such a nice infographics, they cannot put the 4 pages of the procedure and they put just 4 words. And what was left in the mind of many people is just mix caustic soda with seawater, which is just the first part of the process. And the process is very complex. But most of the people who are doing that, they have no idea about the correct procedure. And what happens if you mix such a sea salt water with caustic? So just a second, I had here the plastic bag, which I put down. It's here. Let's take a plastic box. Okay. Here's a plastic box at the hand. So I'm taking now this sea salt, which in composition has a big quantity of magnesium chloride. About 30% is magnesium chloride. And probably we would have a little less, but around 20–25% in the raw seawater. So what else we need? Distilled water. Let's try to dissolve it. We need something to stir it. Okay. Maybe I put too much salt. It needs a little time to dissolve. But we have patience for a minute, I think. It will dissolve quickly. If it doesn't dissolve completely, I can spare your time by just putting some part of this salt solution into this other box. And what is not dissolved is at the bottom, but it's already dissolved too. This is enough. Okay. And here I have a solution of sodium hydroxide and potassium hydroxide in concentration of 5%. Do you see what happens immediately, instantly? It becomes like milk. It's a precipitate. So now what's in here? Who can give a guess? Let's put even more. So probably you have a lot of nanomaterials. Because in the processes of precipitation, you produce materials in nano size. Chemistry didn't ever study for the size and the shape that belongs to the physics. This happens when you separate the sciences and they just study the chemical properties. But from the viewpoint of physicists, these particles are in nano shape. You can filter them, you can dry them, or you can separate them by ultrasound, and then to filter it with special filters to get special size of nanoparticles. But what are these? So what we put into? So a big pot of what we put inside, what was it? CO2, we didn't put any. So you understand? You cannot have any CO2 there. It's not a process for making a CO2 Gans, yet many people do confusions. Let me find here, I have somewhere a piece.
You mentioned that there was a large percentage of magnesium, so I suspect that that might have a lot to do with it.
Yes, yeah. Share my screen. I wrote here earlier. So the chemical reactions from the chemical viewpoint is we have magnesium chloride, which is soluble. It's a transparent solution. Then we add sodium hydroxide. It makes a double substitution reaction. So the OH goes to magnesium and the two chlorines go to the sodium. As a result, you will have magnesium hydroxide and sodium chloride. Sodium chloride, it's easy to dissolve, it's soluble in water, but magnesium hydroxide is not soluble. So the most of your white precipitate, it's a magnesium hydroxide. There are other things as well, but calcium hydroxides, because that is also produced because you had such a calcium chloride before, and now it became a calcium hydroxide and sodium chloride. And also the magnesium, now from bromides and from chlorides, it became magnesium hydroxide. These are insoluble. So that gives the milkish aspect. So most of the thing which you get there, and if you leave it still, it will settle probably after some hours or some days. That's maybe the insoluble part of magnesium hydroxide and calcium hydroxide nanoparticles. But you have also many other things which were even not part of the certificate of analysis because they are in small quantities. So this is not what people pretend to be on some Facebook groups.
But it's fast.
It's fast and it's spectacular. You see something white and people say, wow.
Yeah. So yeah, this is something we don't recommend in the Keshe Foundation. Mr. Keshe has talked about this many times, and thank you, Shandor, for explaining that.
Yeah, in my thing.
We'll engage in.
So never ever use for any health applications any Gans materials made with sea salt or with sea water. It can be sea salt if it's certified to be 99% sodium chloride. Yes, it can be extracted from the sea, but not the integral sea salt. As you see, they are separating it into different parts.
Also, you don't want to use table salt that has iodine in it.
Iodine is not the biggest problem. They are the other agents which are put inside to prevent salt to stick together in the humidity. And sometimes they use some cyanides, which can be transformed in different kind of cyanides and so on.
Yeah. So, but the bottom line is, whatever you put in this box, it's going to be making a Gans of. So that's why you want to have as pure of ingredients as possible.
Yeah. If you want to control the result, you have to control what you put in. Sorry?
There's no caustic in there, so you're not making Gans. You're not making Gans of magnesium, for example, but it will transfer its field into the CO2 that you're creating. It's going to have an aspect of the field in there because anything in the box will put some field strength in there.
Yes, but if you want to use a magnesium chloride, in that case, it's better to buy a laboratory grade magnesium chloride. and not a mixture of all kinds of salts. So buy something like this. It's a magnesium chloride. It's a reactive and analytical grade. And then you can use that if you have a purpose to use magnesium in a mineral form. Probably you would like better to use magnesium or calcium or other elements which are in an organic form. It means processed by a living organism, like made by different plants.
So I'm sure we'll come to it next week in the health. So what we're saying here essentially is know your salt content. And if you want to target a GANS, then use a pure sodium chloride or magnesium chloride or potassium chloride. So that way you know what element you're leaning towards. Is that what I'm hearing here?
Yeah. By the way, about that sea salt experiment with magnesium hydroxide, if you want to turn back that magnesium hydroxide into magnesium chloride, it's very easy. You just add some hydrochloric acid. So here I have a household hydrochloric acid labeled in Hungarian language. It's available in our household shops. So this is to wash up the limescale from the toilets and for such a harsh cleaning jobs. We have this which we prepared before. Let's add some. Let's find our stirring stick. What you see?
Like magic.
Yeah. So the previously formed magnesium hydroxide, which is insoluble, that turned back into magnesium chloride. And what you have left?
You have water.
No, it's a salty water.
I'm just kidding.
It's salt water. Just you have to adjust exactly the ratios of the used sodium hydroxide and sodium chloride to get in balance.
Yeah, this is getting a little out of bounds for beginners, I think. So we probably should.
Yeah, we do have some other people lined up here. Thank you, Sander. It's an excellent question. I'm glad you got that cleared up. There's a question here. It says, in a video before you explained that the nano layer layering on the copper are gaps for magnetical containers. Why are these magnetical and not gravitational containers?
Gravitational and magnetical are just the two sides of the same coin. So
they're all fields. It's just one in and one out.
It's the difference is the direction from the point from where you view. It's a matter of viewpoint. It's like a stick. You have to be careful to stay not on the wrong side of the stick. You know that saying.
Yeah. Another question, if I'm not mistaken, the nano-layered plate was considered negative and the zinc plate positive in the previous slides. Was that a mistake or did I misunderstand?
So I don't understand that question. So
meaning
depends what you call positive and negative.
Yeah.
If you are in doubt, I suggest you, it's very easy. Take a voltmeter. You have the marked chords of positive and negative. You put the plates into the water. You put it on a millivolt scale. And then you measure. And you will see what's the direction of the polarity if you are for the electric polarity. So you will get in a second the answer. So which is positive or negative relative to the other. You can get that in a second. So in case of doubt, know how to get more information. That's what you have to learn, and that's the most important thing to learn. Not to memorize things. It's better to learn how to verify, how to check, how to measure.
Okay.
Can I comment, please?
Yes. Go ahead, Jalal.
Good day, everyone. Good day, Sandor. There is one thing. Why there is so much restriction about doing the ganses, CO2 or zinc or copper or anything. When we came to the teaching, there wasn't such a restriction. What you are saying, Sandor, that's only who have money, he can do the ganses.
Who said that?
Wait a minute. Wait a minute, please. You said you must select the salt, you must select the water, you must select the plates. This is only who have the condition who can select. But there is so many people. Wait a minute, Sandor, please. There is so many people, they don't have this accessory. Some lands who has near the seas, they don't have all this luxury of what kind of salts, what contains, what and that. And there is so many, but Herbert, he cannot do anything because he's restricted. He must use some kind of salt. This you cannot do, and that you cannot do. No, it is not like this. You are right, 100%. 100% you are right. I'm not saying different, but if you want to make GANs, you said, okay, you can do that, but it's better to do that. It's better to go higher because this.
Thank you. I understood it. No need to expand it in 5 minutes more. I understood in the first half minutes. So here somebody says the issue that it's so difficult because I need a pan, I need a fire, I need some oil, I need an egg, and then I have an omelette. It's not so complicated. We say how you can go to get a finer results, more accurate results. It doesn't know that is restrictive. If you know how to make a higher quality, it doesn't mean that you have to make the highest quality into the world. Look at the price of iron. How many dollars per kilogram? And if you look for isotope, let's say 58 of the iron, look at the price. It's 1,000 times more because it's separated of only that quality and nothing else.
Sandor?
Let me continue. Don't interrupt me, please. This is just the intro. Please hold your question. I'm ready for it. So if we say how you make a better GANs, it doesn't mean that you cannot make any kind of GANs, because any GANs is better than no GANs at all.
Now you say.
To know to make the difference between wider tolerance in the quality terms or a narrower tolerance of the quality, and that's also always relative.
Yes.
We strive to the perfection, but we never can achieve perfection.
Yes,
but it's important to do it. So you can use any kind of zinc. If you don't have a pure 99.99% zinc, use any kind of zinc which you get. If you have no special high-grade copper, use any copper you have. You have no distilled water, you have no clean water, use any water you have. And still you can make the GANs. If you are not sure about your salt, use any salt you have. But if you want to fine-tune it for laboratory quality, for pharmaceutical quality, in that case, of course, you go and you look even for the environment to be without dust, and you cover your head for nothing to fall, no dandruff to fall from your head, or no hairs.
Thank you. That is right.
So you can do it. You can do it in a forest, in a rainforest, if you can make a fire. Of course, there are degrees between what you can make it like a school demonstration, or like to learn what it is, and what you can do it like for a specific medical application, or for a specific health application where you highly fine-tune a specific spectrum of the field strength. Look at the purpose. What's your purpose with it? So if you want to protect a piece of iron of rusting, so there are so many special paints for preventing corrosion, but finally any kind of paint is better than no paint at all. If it's about your fence outside, you just paint it if whatever you have left over from last year, if you have any, and you don't spend now for the most expensive one. And still you protected it. But of course you can choose the highest grade corrosive protection paint, and you have a guarantee for 50 years it will not rust. That's your choice for how much you want to spend on it. Actually, for making this one, the most expensive part was to get a piece of zinc. So if you buy a battery which costs 50 cents or $1, this size battery, that's the highest expense you have to make just to get zinc, because copper you can get from scrap. To get a plastic box, if you cannot afford 20 cents for a food box, a polypropylene, then you just get a plastic bottle, you cut it here, and you have a cup. Plus you have a funnel from the other end. And it doesn't cost you nothing.
And what about the classic question in the live stream, Shandora? Can graphite be used instead of the nano-coated copper to make GANs?
So Mr. Keshe explained us about the field strength of the fields of the nano copper. What does it have to do, graphite, with that? So probably graphite, it's a different method. It's something else.
Okay, I think that's...
Mr. Keshe never taught you to use graphite for making GANs. Of course, people are doing their own discoveries, they have their own ideas, they do experiments, and they realize something. So there are many ways to do it, but you have to decide who you follow, the teachings of Mr. Keshe or the teachings of Shandor, who invented a new way about something, but yet he has no full understanding of what Mr. Keshe teaches. Of course,
Rick,
you can in many ways you can produce GANs materials.
Mm-hmm. There
are many ways,
knowing what you have.
But
yeah.
if you use now, not about graphite or whatever. I saw just a second about
this is where certification comes in and so on too. If people have a different process, then they can't be, you know, selling their GANSs and so on, and it's not certified the same. Mr. Keshe has gone through a series of processes on this, on the materials that he uses.
Look, we are in the 21st century, and in most of the countries there are certain regulations. Even if I buy a salt, or I buy a piece of bread or whatever, usually it has a label for which standard it complies to. And the factory, was it certified or not, or the product, was it certified or not, especially if you buy something which you want to connect to the electricity or it creates fields. You see such kind of marks on every product, like a CE, for instance. Or you have other kind of conformity signs for other countries. But most of your products have such a CE certificate or whatever. For if you're Europe, if it's for United States, you have some other ones. So if you buy something which you don't know how it was produced, which kind of quality assurance the producer has, then don't comply to anyone. If you buy something for your child and you want your child to stay healthy, so are you verifying what quality of thing you buy for? Even bananas, they are $2 per kilogram bananas, and they are 50 cents per kilogram bananas. You can choose by price, or you can choose to see that which was produced with more chemicals or less chemicals. Is it so?
Yes, indeed. Thank you, Shandor.
All the products which are sold through the Keshe Foundation's web stores are all certified according to the procedures required by law in every country. The way it applies, the CE, for instance. If you go to Russia, probably you have a ROS standard and not a CE. So it needs a different certification to ship in that country. All the products from the Keshe Foundation are certified. Underwriter laboratories or CE or TÜV or whatever. And in many countries, it's a requirement by law for certain goods, especially if you sell something for health or to be consumed or to be in touch with your body. In that case, they have to be certified. Otherwise, if you selling such an unverified, uncertified product, it's enough one single customer to be dissatisfied and to make a claim, and you will go to the same route like it happened to the Keshe Foundation in Belgium, the court. I hope you understand me. You can make whatever you use for yourself, and you are responsible for that, but when you give to somebody else, you have to be sure you don't cross the line.
Yeah, and that the Keshe Foundation can't promote a website that hasn't got certified products on it, is the way I understand it.
Absolutely no. But if you are a producer, if you produce different things, plasma technology, and you get your product certified, sorry, just a second more, you certify your products, Keshe Foundation then can help you to market your products. So keshefoundation.org has 1,000 times more visitors than your website can have. And you can get there, just get your products certified before to offer them to the public. Yes, it costs, of course. Every business needs an investment. But it's something which has to be done.
Thanks for clarifying that. Okay, maybe
I have another question.
We can take one more question and then that will be the end. Thank you.
Should it be mine?
May as well.
So the question I have is, when you are wanting to fine tune your making of your Ganses, do you need to separate your Gans boxes if you're making different types of Ganses? Do you need to separate your final Gans when you're storing it? Question.
Okay. Thank you for the question. To give you a short answer, which will tell a lot, I recommend you to watch the Knowledge Seekers Workshop number 190, the 119th Keshe Foundation's Knowledge Seekers Workshop. You find it on YouTube. You will have the answer there in details.
That was 119.
190.
Oh, 190. Okay.
119th. And the following is connected to that. So you have
119.
working with fields. To give a longer answer,
No, you said 190.
Information. When you are working with fields, we have to be aware of the fields which are in the given environment. And if you have a Gans kit like this one on the table, you know that the nano-coated plate makes some fields, and also the Gans which you produce is also producing fields, such a fields that you see it's collecting already such a amino acids on the top, like the grease on the soup, like the oil on the soup. It's something which is picked from the air, and it doesn't come from the salt, it doesn't come from the copper, it doesn't come from the zinc. It's attracted by the fields from the environment. So now, if you make another box in the same room or near to it, don't you think those fields will interact with it? But there are specific ways how to create conditions to have specific fields in a small area, and for that you use other fields deliberately created around it to produce that environment. You create such skins or layers of other kind of fields, and I recommend watch Mr. Keshe's explanation in the 190th Keshe Foundation workshop, Knowledge Seekers workshop. Knowledge Seekers
Very
workshop.
good. Thank
Yes.
you. So what happens if you're making your CO2 Gans box and you make it in a greenhouse that has lush vegetation? Are you likely to get less CO2?
So if you have a greenhouse, probably you know the conditions within, what the plants do in the daytime, what they do in the nighttime. In the daytime, they consume CO2 and they release oxygen. In the night, it's the reverse. They absorb oxygen in the night. If you want to have an environment rich in CO2, of course, if you go into a greenhouse, you have more, but who are living somewhere on the 20th floor in a huge house, they probably have no such a possibility. If you are so lucky that you have a greenhouse, test your GANS kit in the greenhouse, or also you can test it at the ground level or in the cellar or on the roof, and you will see the differences.
Also, a lot of greenhouses are augmented with additional CO2 through propane heaters and this kind of thing as well. They deliberately add the CO2 for the plants that love it during the daytime when they eat it up. Okay,
Yeah.
I'm wondering if we should...
Yeah, we should probably wrap her up here.
Yeah.
I do have one basic question. If you could quickly explain the difference between PM ticks and plasma. It was a question that came up back in your slideshow there when you're defining the terms.
What's the difference between a brick and a house?
Perfect answer, I think. We should let everybody just ponder
bricks
for the next week. I was going to say the pimetics are inside the plasma, or parts of it, let's say. But that was the perfect answer, I think. Yeah. It's one of those Zen cone things to ponder. You know?
Yeah.
All right.
You know the answer. You know the answer. I don't have to tell it to you. I just have to point where to look for.
Right. Can we call it a day? We've gone
Yes.
on longer than we expected.
Yes, we do apologize for the extra length today, but we had a lot of questions and concepts that needed to be understood. Okay.
Right. So thank you, Flint. Thank you very much, Sandor, for all the information that you've brought to us today. And thank you, Lisa. And it's always the new, the GANS, and same as the Nano would always bring up a lot of questions. And so hopefully we've put a lot to rest today. And thanks, Flint and Rick, for your help in the background.
Yes, wonderful.
You're welcome. Thank you for a great show.
Okay. This has been the Understanding Plasma Science, Part 5. Of course, with Plasma Science and GANS. This is the Keshe Foundation Spaceship Institute Public Teaching in English for Monday, October 23rd, 2017, with Jim and Lisa McDonald and Shander Kakasi. So thank you all for coming. We'll see you here, same time, same place next week for Part 6. And coming up, the next public teaching here is going to be tomorrow afternoon. It'll be 4 p.m. Central European Time. It's going to be the 13th One Nation, One Planet, One Race for World Peace public meeting. So hope to see you all then tomorrow afternoon, Central European Time at 4 p.m. And we'll go out here with a little bit of music. And again, thanks all for coming.